Well, I'm very happy to be here. My name is Maggi, and the title of my presentation is going to be Codex Alimentarius, but specifically, we are going to talk about the guideline to assess the recombinant DNA animals in order to assess the safety of the food derived from them. So we are going to give an overview of this guideline. So today we are talking about some introduction of the 68 of 2008 guideline, that is the specific guideline for the safety assessment for the animals. We're going to talk about a little bit about the general criteria and some considerations that are specific for this kind of risk assessment. Then we are going to see the general framework of this guideline and some key elements of this guideline and some conclusion at the end, okay? So, going into the introduction of this guideline, as you may know, it was developed in Codex Alimentarius. It's an international or intergovernmental body that depends of the FAO and WHO in order to develop some standards or guidelines for safety of the foods and to maintain a fair trade in the world. So at that time, some 2000 or 1999, started the Codex Alimentarius opened an ad hoc intergovernmental task force in order to work on how to assess the safety assessment of the GMOs. See? Specifically, they started working on some principles and how to conduct a safety assessment and develop a document in order to write down how to conduct a risk analysis and then how to perform safety evaluation, safety management, and risk communications, okay? About in relation with the GMO foods. Then they started to develop some specific guidelines for different species. They developed the plants guidelines, then the microorganism guidelines, and finally adopted the guideline for to conduct the food safety assessment of food derived of recombinant DNA animals. There were 7 meetings that started in 2000 and the last one was in 2007 in Japan. So this guideline, the specific guideline, the 68 for animals, was adopted in 2008, and then this task force was dissolved. Okay. If you want to know in much more detail about Codex Alimentarius and the role of biotechnology, you may enter in the webpage. They have a lot of information and all the documents and guidelines are there in different languages in order to download them. Okay, going into the general criteria and consideration, specific consideration for recombinant DNA animals. Well, the guideline was primarily developed for being applied for animals with the intention for use for food. Okay, there are no provisions for animals used for non-food use in this guideline. So the scope addresses only the safety of the foods that consisting of or derived from the recombinant DNA animals, and then some consideration about provision about the nutritional values of the food derived. And it has some paragraph that say that all the issues that are out of scopes of this guideline, that maybe it says that there are important issues, okay, but are out of the scope of this code guideline, that are animal welfare, they have no provisions, ethical, moral, socio-economical aspects, there is out of scopes, anything that have to do with the environmental assessment, they have no provision for that. And as well, the safety of the recombinant DNA animals that may be used for feed purposes, okay? Or the safety of animals fed with feed derived from the recombinant DNA animals, plants, or microorganisms, okay? It may be, in practice, when we conduct the food safety assessment and reach a conclusion, it could be possible, depending on the case, that this conclusion also is good for reach a feed safety conclusion, but it depends on the case. So, continuing with the general criteria, these guidelines applies for animals that have a history of safe use as sources of food, okay, that have been modified by modern biotechnology, and was developed primarily for animals that have a heritable DNA, recombinant DNA construct, okay? Have the food derived from animal bearing non-heritable constructs, it said that may require some additional considerations. It doesn't go with much more detail, but in that cases, it may be necessary to ask for more information. And well, the approach is the general criteria of this guideline is very similar. It has very similar approach from the plants guidelines. And it makes sense that when start to develop this guidelines for animal, they used as a starting point the plant guidelines because there were a lot of work already done and a lot of experience. So a lot of those who are familiar with the plant guidelines will notice that are a lot of similarities in terms of approaches, criteria, and information provision that are written down in the Codex guideline. So the idea is to identify and characterize the intended and unintended effects and evaluate if they have some biological relevance, and if they represent a new or altered hazard in order to reach a safety conclusion, or if they have some concerns about the nutritional aspects of the product. The same approaches and criteria of plant guidelines. So continuing with the general criteria, have the same approaches, the comparative approach, and substantial equivalence, they work on this, you know, in order to follow the same aspect and same approaches in order to evaluate this product. The safety assessment is carried out to identify the similarities and differences between the GM animal and a conventional counterpart. So when we are talking about conventional counterpart, specifically in this guideline, they adapted the definition of conventional counterpart in order to be more, how do you say, adapted to the animal situation, okay? So the conventional counterpart is an animal breed with a known history of safe use as food from which the recombinant DNA animal line was derived. As well as all the breeding partners that were participating in the breeding process, okay? And in order to generate the animal ultimately used as food. So it gathered all these probably conventional counterparts in order to conduct these comparisons between the recombinant DNA animal and the conventional counterpart. Then have provision about unintended effects and case-by-case assessment. So the approach is because unintended effects can result from the random insertion of DNA sequences. So may cause some problems, some disruption or silencing of the existing genes. Well, modification of the expression of the existing genes. So that's why it follows to continue with the step-by-case assessment and in order to analyze the unintended effects. And in relation with a stepwise approach and the ways of evidence, that's it because there is not a single test that give us all the information that we may need. So we need a variety or a collection of data, and we can all these together may provide us assurance that the food is unlikely to have an adverse effect because of the consumption. So at the end of the day, the idea is to conclude that the GM animal and the new food derived from it are safe and nutritious than the conventional counterpart, or more nutritious, maybe. Depends. Yeah. Not less nutritious, I think. In Argentina, we conclude that it's as safe as and not less nutritious, because it could be more nutritious. So going in more detail about the framework, the general framework and the elements of some key elements of the guidelines. There are three main aspects that we should consider or should take into account. First one, the nature of the recombinant DNA construct, and if it has some expression products, the health status of the recombinant DNA animal, and the composition of food produced from recombinant DNA animals, including some key nutrients. Okay, so here we have a new issue, a new consideration, new provision that is in relation with the plant guidance that is assessing the health status of the animal that may provide us a very good insight in terms of safety of the food that derive from this animal, and if it may have some toxicants or some bioactivity, some of the main of the expressed substances. So, going deeper in this framework, the guideline asks for a general description of the recombinant DNA animal. Well, all the molecular package of information that is the same information that we ask in the plant guidelines, and it adds some provisions about the breeding steps of the process in order to get the recombinant DNA animal ultimately used as food. So the guideline focuses, the safety assessment focuses in the animal that is going to enter into the food supply. Okay. Have some new definition about the initial recombinant DNA animal that may call founder animal, and then the ultimately animal used as food. And in relation with the information that we may have gathered to assess the safety assessment, what we will ask information about health status of the recombinant DNA animal, expressive substances, of course, composition analysis of the key elements, food storage and processing, intended, if it was intended, nutritional modification information, or some, if it corresponds some study with the whole food, and other considerations. So there are provisions about the general description of the recombinant DNA animal, the description of the recipient animal prior to the modification that is used as food, and the sources of the DNA, and then the description of the breeding process that will ask for information on how the initial recombinant DNA animal, the founder, leads to the production of the animal that is ultimately used as food, that is going to enter to the food supply. Well, all the molecular characterization and information that that is asked as well, the same approach as plant guidelines, characterization of the modification, information of the DNA insertions into the animal genome, genetic construction, number of sites, etc. Information of the novel substances that are expressed, level and site of expression, biological function. Well, the animal health status is because normally animals that have a history of safe consumption generally do not contain genes that express toxic substances. So assessing and comparing the animal health status may be a very good indicator for a potential safe consumption. Okay, so compare the health status and the performance indications of the GM animal and the conventional counterpart is a good approach in order to see and evaluate if the animal is healthy or not. And this is going to give us some insight or information about the safety of the food. In relation with the assessment of the toxicity, the potential toxicity, in comparison with the plant guidelines was added that as well the bioactivity assessment of the substances. So novel substances expressed might be evaluated. It depends of the case, but may be evaluated for potential toxicity or bioactivity, because it may be active in humans after consumption. So, but if there is a history of the safe consumption of the substance, it is not necessary to conduct the toxicological study. So it's the same approach as plant guidelines. And all the information that we may need is based on a weight of evidence approach, and may ask for some in silico studies or informatics, thermal stability and resistance on gastric or intestinal models. If it's necessary, some studies in acute toxicology studies. And then as well, the health status of the animal is going to give us more evidence to the package of all the information that we may need. In order to assess the allergenicity is same as plants, nothing changed, nothing added. So we may ask different information about the similarity studies of bioinformatics studies, comparison with allergen databases, identification if there are no allergens on the donor of the genes, or so there are new allergens encoded by the transgenes, and other package of evidence that may give us more weight of evidence in order to conclude. In relation with the composition and analysis, the idea is to compare the recombinant DNA animal with a conventional counterpart. So the idea is to compare the key elements or the key nutrients, anti-nutrients, and allergens that are important to the species. But ideally, the conventional counterpart selected should match in-house boundary condition, breed, age, etc. But sometimes it could be difficult, so maybe cases that we may need more than one comparator. So when there are statistically significant differences, we have to analyze to assess if there are some patterns or changes, and analyze if these changes made or significant, statistically significantly changes may be or may have some concerns in relation of biological or may have some biologically relevance. So have to take into account that the number of samples may be limited, because we are talking, it depends on the species, but it may be limited, and there is likely to be a large variation between animals. So when conducting this assessment, we have to take account these considerations. And the idea is to evaluate this if there is a difference in the context of the natural variability of the species, if there is data available. So when the mean values are not included in the ranges of the comparison made and the bibliography, it has to be verified that the statistical differences are not biologically relevant. And in the cases when there is an intended nutritional modification, it could be necessary to ask for feeds trial with using the whole food in order to reach a conclusion. When the nutritional profile is intentionally modified, and not comparable with the conventional foods. So the nutritional value, nutrient viability, and the safety are compared, and use conventional food whose nutritional composition is closer as a appropriate comparator. And taking into account the other considerations, Codex says that may be potential altered accumulation of the distribution of the xenobiotics, for example, veterinary residues of drugs, and which may affect food safety, and maybe a potential of increased risk of zoonosis by microbes when independent of the transformation that was made. And another provision is in relation with the use of antibiotic resistant marker genes, because the genes transfer for animals and their food product to gut microorganism or human cell may occur. It's very unlikely, but this is the provision in order to assess that this kind of marker genes. So, final words. We have to say that today there are not much more experience about the application of the Codex guidelines in order to assess animals, because there are not so much animals in the market. But I think that the regulatory agencies that are familiar with the assessment of and using the Codex guidelines for plants may have a starting point or a basis in order to apply this guideline when the case is submitted. And as well, the general assessment criteria and the approaches are similar to the plant guide, but there are some specific provisions in this guideline that are such as the health status, the bioactivity assessment, the definition of the conventional counterpart, breeding processes, and another consideration. But in general terms, it's almost the same approach, the criteria and the information that is asked, the same as we are doing with plants guidelines. And I think it's the last one. Thank you very much. And